In today's lecture, we'll start entity relationship model, how we can build that model and what are the components and what are the elements required to build entity relationship model. So first of all, we can have a view about the points will be discussed in this lecture are entity set, relationship set, design issues regarding the entity relationship model, mapping constraints, keys and ER diagram. And the extended features and the design of the database schema and the reduction of ER schema to table will be discussed in the next lecture, right? So first of all, we will discuss what is an entity set. Let's suppose we are making a ER diagram for a particular college, any banking enterprise and other hospital, right? So what will be an entity for that? If we are talking about a college, student can be an entity and a teacher can be an entity, right? So whenever we are modeling our database, it will be as a collection of entities as well as the relationship. It will be the collection of entities and relationship among these entities. So whenever we are building a ER model, it will be a collection of entities and we will make the relationship between those entities. So this is how we will represent the ER model for a particular enterprise like school, college, hospital, bank and any other company, whatever, right? So an entity is nothing but an object basically, right? So if we are making an ER diagram for a college, so a student can be an object. There are several students in the college. So that particular object, let's suppose Arjit is a student, that will be an object. So object that is distinguishable from the other object, right? But when we talk about the object sets, similar type of objects, right? So that will be a student. So an entity is a set of entities of the same type that share the same properties. So if we talk about Arjit, it will be an object. If we tell student, it will be an entity set, because a student is having a student and all the students are sharing the same properties, right? So there can be another example like set of all person, companies, trees. There are various kind of trees, holidays and many more, right? Every entity can be represented by its property. So these properties are nothing but the attributes. So entity will be represented by a set of attributes. Let's suppose a student. What attribute it can have? It can have its name, its roll number, its contact information, its address, marks, subjects, degree, whatever is required to build that particular system, right? So there can be some attribute according to the need of the enterprise, right? So the entity can be represented by a set of attribute, that is the descriptive properties posed by all the members of an entity set. Okay, for example, a customer can have an attribute, customer name, social security number, customer street, customer city, Aadhaar card, PAN card, etc., right? If an entity is an account, then what will be the attribute? Account number, balance and any other also, right? So this is what about the attribute. Now the domain is nothing but the set of permitted values for each attribute. If we talk about name, right? So name, what will be the domain for the name? String, nothing but the string. We cannot have digits in its domain, right? When we talk about this account number, what will be the domain? Set of numbers. it can have some digits also, it can have some number, that alphabet also, like account number can be like A102, it can be an account number, right? So every attribute can have its permissible value. Like mobile number, if we talk about the mobile number, what will be the domain of it? Only some numbers, and it is fixed 10-digit number for a mobile number, right? So this is what the domain. Now attributes, we are talking about the attributes. Every entity has some set of attributes. These attributes basically are having these types. Okay, so first of all, simple attribute like name. My name is Anupama Sharma, right? So it can be a simple attribute in some application when we are taking name as an attribute. It can work as a composite attributes also if we are dividing the name in first name, middle name and last name. It means what? An attribute which can be further divided into subparts. These are composite attributes. Simple attribute like balance, account number, it cannot be further divided, right? So these are simple attribute and composite attribute which are further divisible, right? Any other example for the composite attribute? Address. Address can have its street number, city, state and all, right? So it can, address can be an composite attribute. Now the single value and multi-value attribute. Single value attribute, as name suggested, it can have a single value like name. Name can have only one value, right? Multi-value attribute, it means multiple values are allowed, right? If we talk about contact number may be 2 for any person, 3 for any other person, right? So it can have the multi-value attribute. I'm having one contact number, another person can have 2 contact number, and some another person can have 3 contact numbers. So it can be possible to have multiple values for the contact numbers, right? Okay. Some null attributes, right? Some attribute, in the domain of some attribute, null values are possible, like address 1, address 2. We our company is making a database in which 2 addresses are required, but as I can have only one address, so I will fill one address and one another one I am not having the another one address, then it will be the null, right? So some attributes will have sometime null values, right? The name cannot be null, right? So by this way you can understand the null attribute, right? Derived attribute. Now if we are having date of birth of any student of or an employee or a teacher, so if we are having date of birth, we can derive age. So we need not to keep this age in the database because it keep on changing every year, right? So some attributes are derived attribute like age. So in ER model, we need to show which attribute is a derived attribute or which attribute is the simple attribute, which is the composite attribute. There are different symbols for each and every type of attribute in the ER model. We'll discuss in the further slide. Now, we have understood about the entity set, its attributes. Now, it turns to understand the relationship set. Right. Relationship is an association among several entities. Like if we are having 2 entities, a student and teacher, we'll have some relationship in that. So we need to show that relationship in the ER diagram or ER model of a college, right? Here, this is an example. If customer is an entity set, customer name is Hayes, and that customer is having an account in a bank. So this is his account number. So what will be the relationship set? it can be a depositor relationship. So this name can be suggested by the designer of the ER model, right? So this customer can have a relationship with the account named depositor, right? So this is what the one relationship. Okay, so relationship set is a mathematical relations among two and more than two activities. There can be a relationship between two activities which can be shown by the diamond sign, and there can be more than two entities, entity 1, entity 2, entity 3. These three entities can be related with each other. So here, that's why here we have written n should be greater than equal to 2. At least two entities are required to have a relationship, right? But sometimes we have only single entity which is having the relationship. We'll see in the next slides. Okay, so mathematically we can show that E1, E2, E3, En and so on, and this E1 is the element of this capital E1, E2 is the element of capital E2, where these E1, E2 till En is a relationship. For example, we can have this customer and account number. This is the element, or it is the element of this depositor relationship, right? Okay. Now, sometimes this relationship set, as this is an entity account, and these two entities are having a depositor relationship. This entity is having these 4 attributes. This entity account is having these 2 attributes. Now, this relationship may have some attribute, right? So, if it is having some attributes like access date, we can show here, right? Access date. So, sometime relationships also may have some attribute. Sometimes relationship set may not have an attribute. So, depend on the enterprise demand or situations or the scenario. Now, the degree of a relationship set. It refers the number of entities set that participated in a relationship set. Let's suppose only one entity is participating in a relationship on different roles. We'll understand it in the next slides. So, it may happen. Sometime it may happen that two entities are involved in the relationship. Sometime it may happen more than two active entities, like 3 entities are involved in a relationship. So, degree of a relationship refer the number of entity sets that can participate in a relationship, that are being participating in a relationship, right? So, on the basis of it, it can be unary relationship, binary relationship or n-ary relationship. So, sometime it may be the situation in some organization where 3 or more than 3 entities are the part of a single relationship, right? Now, the roles. Roles are basically required in this situation when only a single entity is involved in a relationship. We need to further specify on what role this particular entity is having the relationship. Okay. So, here we can see that employee is an entity which is having these 3 attributes, right? So, employee means what? A worker may be an employee, manager may be an employee, and some other designations also, right? So, if we want to show that worker to manager relationship, how we will show through the ER diagram? We will show by unary relationship, because if we talk about worker, it is an employee. If we talk about manager, he is an employee, right? So, both are employee. So, how we will differentiate the relationship between employee to employee? How? Will make unary relationship with this roles. So, roles can be presented on these arrows. Okay. So, let understand employee is an entity, it is related with the other employee with the work for relationship. So worker is an employee who work for the manager. So there are many workers which are associated with single manager. So what kind of relationship it will be? Employee work for another employee. So employee work for who works? Workers, right? Work for which he is working or they are working for manager. So there will be one manager for many workers. So that's why we have shown it many to one, right? So this role is basically required. These are the labels which call the roles like manager, workers. These are required to specify what kind of interaction is there with the entity set and the relationship set. So this is totally optional. If we need to clarify the roles, then only we will write the roles on these arrows. Otherwise, it is totally optional, right? Okay. Now, design issues. Whenever we are making ER model, there are some design issues. Let's suppose we are making an ER model for college. So we need to identify the entity set for that particular scenario. So uses of the entity set and what are the attributes which will be stored in our database. For a particular enterprise, it may differ from other enterprise. If we are making ER model for our college, for AKGEC, right? So we are having student number there, we are having roll number. So two different numbers for a single student we are having. In some other college, student number may not be there, so only roll number will be there. So if we are making a ER model for our college, what will be the requirement? We need to store the student number as well as the roll number, right? But we are making that ER model for another college, it may be only roll number. So depends on the enterprise, depend on the company for which we are making the ER model, we will decide the attributes. So we will decide first the entity set and we will decide attributes for each and every entity, right? And the another design issue is the entity set versus relationship set. So what will be the relationship between those entities? So first of all, we need to select the entities, then we need to select the attribute, and then we need to decide the relationship between those selected entities, right? Okay. Now, after that, we need to decide the degree of the relationship between those, right? So it is possible to represent the binary versus n-ary relationship set. So according to the need, we'll decide which type of relationship we will have, right? Okay. Next is the mapping cardinality. Whenever we are relating two entities with a relationship, we need to show the cardinality on these lines. This relationship is one-to-one relationship, or this is one-to-many, many-to-one, or many-to-many. So this is what the mapping cardinality. It is to express the number of entities to which another entity can be associated by a relationship set, right? It is most useful in describing binary relationship set, right? So cardinality can be one-to-one, one-to-many, many-to-one, or many-to-many. Now, how we will represent it? So whenever we need to represent one, so there should be this arrow, and if we are representing undirected line, it means what? Many. Okay. Now, if we are going to represent a one-to-one relationship, it means a customer is associated with at most one loan by this borrower relationship. So if we want to represent this one-to-one relationship, we will make this arrow sign both sides, at the customer side and the loan side. It means what? We are showing that a loan is associated with at most one customer by borrower relationship. So it is what? One-to-one relationship, right? Okay. Now one to many or many to one relationship, how we will show that? Wherever we want to show one, we'll write this arrow, and wherever we want to show many, it means we are writing undirected line, right? And similarly for many to one, here we are showing many customers are related with a single loan. Many customers are involving in a single loan. Here what we are showing, a customer may have more than one loan. So there is a difference between the basic concept, right? Here we are showing a customer can have more than one loan. Here we are showing many customers can have a single loan, right? So this is the explanation for the one to many and many to one. Now this is what? Many to many relationship. If we want to show the many to many relationship, what we will use? We will use both side undirected lines. Okay. So here we are showing that a customer is associated with several loans by a borrower relationship. A loan is associated with several customer by a borrower relationship, right? So this is how we are representing many to many relationship. Now existence dependency. This is very, very important concept for the modeling of any database, right? Okay. So there may be possible like here we can take an example, loan. Loan is an entity, and here payment for that loan is an entity set. There may be multiple payment, there may be single payment for a loan. In general, it is multiple payment for the loan, right? So there is a relationship, loan payment relationship. Now what will happen? This loan is completed, or anyhow we are going to delete that loan. So payment is an entity. If it exists in the database, then what will happen? There are some payment information, but I don't know for what loan it is existing. So what will be the requirement? If loan entity is deleted, then its all associate payment entities must be deleted, right? Because this payment is totally depend on the existence of the loan entity. Okay. So here this loan, what is this? This is the dominated entity, and this is subordinated entity. Payment is subordinated entity, right? So we can take an example like I'm working in a college, so I'm an employee here, and they are storing my dependent information, right? So let's suppose I'm having two dependents, right? So as I'm employee here, so my two dependents information will be stored in the database. When I left the job, so those two dependents information should be deleted with my record from that database, right? Because I'm as an employee is a dominant entity and my two dependents are subordinated entity. So we need to show this existence dependency in the database, so that when the dominant entity is deleted, subordinate entity automatically will be deleted from the database. So for our easiness, for the DBA's easiness, will show in ER diagram like this, so that when this ER model is converted into the tabular form in the relational database model, then it will be work fine as per the requirement, right? Okay. Now this is very, very important concept about the keys. When we are studying our DBMS and we are making this ER model for a particular enterprise, we need to have the knowledge about the keys. Why we need to have the knowledge about the key? Because we are making, at last after ER model, we are making the tabular databases. We are making the actual databases. That is in the RDBMS format, it is in the form of tables which are related with each other. How we are making relationship? We are making relationship with the help of some keys. We can uniquely identify a particular entity with the help of keys. So keys are required. Key is nothing but an attribute by which we can uniquely identify that particular entity, right? So there are many types of keys there. If we talk about super key, it is one or more attribute set by which we can uniquely determine each entity. So any key can uniquely determine any entity, right? So this is for all the keys. But why it is super key? Because here we are having one or more attributes. So there are some extraneous attribute. Let's suppose name, we can uniquely identify by name of the student. No, because name can be repeated, right? Now student number, we can uniquely identify our student by the student number. Yes. So this is a key, and we are combining these two attributes for the unique identification. Of course, these can uniquely identify, though this student number is sufficient to uniquely identify a particular entity student, but then also we are adding name with it, then also it is able to uniquely identify that particular student. So the name is extraneous element, extraneous attribute here, right? Though super key is the combination of some attribute which can uniquely determine each entity which are having some extraneous elements also. Now the candidate key of an entity set is the minimal super key. It means if we are removing this extraneous element from that particular super key, it becomes the candidate key. So we can have some examples like same. Okay, so this minimal super key are candidate key. There can be many super key possible for an entity. There are many candidate key possible for entity. So now when we are having minimal super key, we cannot remove further elements to have that candidate key, right? Okay. Here we have given two examples of the candidate key, like social security number, account number. These are the candidate key for different these customer and account entities, right? So although we are having many of the candidate key, from those set of candidates key we can choose a key which will be uniquely identify my entity. That time that particular key is known as primary key. So what is the primary key? Primary key is nothing but a candidate key which I use for unique identification of an entity, right? So that is what the primary key. Now what are the alternate key? Candidate keys minus primary key. Candidate key minus primary key. All the remaining candidate keys are known as the alternate key, which can be used for the unique identification as per the requirement, right? Okay, so I think all the basic key concept has been discussed here. We'll discuss the foreign key further in next slides. Now here the ER diagram components. Rectangle can be used to represent the entity set. Ellipse can be used to represent the attributes. Diamond box can be used to represent the relationship. Lines can be used to represent the association of the entities with the relationship. If it is one to many, so we want to write the one, that way at that end we will use this arrow sign, otherwise we will use that undirected line. Double ellipse used to represent the multi-value attribute. Dashed ellipse will be used to show the derived attribute. primary key, like roll number is a primary key for my student entity set, then I will write by underline, right. So these are the important concept about the representation of the ER diagram. Now we need to discuss about the weak entity set, that is related with the existence dependence, which we have studied. So this entity set does not have the primary key, is referred to as the weak entity, right. So entities which are not having primary key will be referred as the weak entity set. Okay. So the existence of the weak entity set depends on the existence of the strong entity set. Like if I am writing here employee, right. So this employee may have some dependents. So this is what the strong entity, this is what the weak entity. How we will represent this weak entity? With double rectangle, double line rectangle, right. So this dependent will not have the primary key basically. Why it is not having primary key? Because it is a weak entity, it can have the primary, it can have the partial key, which is known as a discriminator. So how we can make the primary key for the dependent? The primary key of a weak entity set is formed by the primary key of the strong entity set, on which the weak entity set is the existent dependent. So the dependent number or whatever, if we are giving some number to this dependent, then dependent number, or we can take one other example like payment. So we can have payments for the loan. So this payment is the weak entity. So that payment number will be the discriminator for this, and loan number with the payment number will be the primary key for that payment entity, right. So by this way, if we associated the primary key of the strong entity set like employee number with the dependent number, then this weak entity set can have its primary key, right. Okay. So the next weak entity set. Okay. So here we are having an example like loan is a strong entity and payment is a weak entity here. Their payment number, payment date, payment amount are the attributes. Like here we can see that payment number will be unique for every payment, but it is not the primary key. It is what the discriminator. Payment number can be same for another loans payment also. So it cannot uniquely identify among the payments, right? So it is what the discriminator. Because this weak entity payment is depend on this loan. So how we can make the primary key for this payment? We can make the primary key for for this payment by associating loan number and payment number. When we are combining these two elements, loan number from the loan, payment number from the payment, when we are having this combination of true attributes, it may be known as the primary key for the weak entity set. So in this lecture, we have understood the basic concept about the ER model, what is known as a strong entity, what is known as the weak entity, how we can show the relationship, how it can be unary, binary, ternary, how we can show the roles on the relationship. So basic concepts of ER model we have discussed, and for the further extended features of the ER, we'll have the next lecture. Thank you.